Hello everyone. In this class, we are going to study the first chapter, 1.2 section, which is basic ideas and terminology. So in this section, we are going to study what is the differential equation, what's the definition, and then what's the solution of differential equation and how to solve some easy and basic differential equation. So in 1.2, firstly, let's take a look at the definition. So definition for the differential equation means its equation include derivative of function. Okay, so let's see. Definition 1, differential equation. Differential equation means is an equation involving one or more derivatives of an unknown function. Derivatives of an unknown function. So usually we say the function is function y equals fx, and let's see some examples. Okay, example 1. So here I'm going to give you several examples about the differential equation. Let's take a look at the first one. dy over dx plus y equals x squared. Okay, so if we take a look at this one, you can see we have the derivative and we have the function y and its equation. And sometimes we can also write down the equation like this way: y prime plus y equals x squared. This is just another notation, right? And the second one, let's see. We have the second order derivative. Okay, actually this is the equation for the spring. Let's see. This is second order derivative. We can also write down this as k squared y. And we can solve for y. Y is a function. That's the solution for the differential equation. Let's see. We can also have the third order differential equation. Looks a little bit more complicated, but they are all differential equations. And here, sine dy dx, changing the inverse y, which equals 1. And then I'm going to give you another one. This is also called the differential equation, but it has different. It's a little bit different from the other functions. So if we look at the first 4, okay, they all means the function, just like if we look at the first 4, they all means the solution is y equals fx. Y equals fx. So this is a function with one variable. And for those kind of differential equation, we call them ordinary differential equation. We also call them ODE. Okay, so for those kind of differential equation, they are called ordinary differential equation. So we sometimes just say ODE. Okay, and then for the last one, we can see actually this is a phi function is a function has two variables like x, y. So you can see that's a partial derivative, right? You just finished the calculus 4. So phi xx means second order of the partial derivative respect to x. And this kind of thing includes a partial derivative, so it calls partial differential equation. It's also called PDE. But in our math 244, we don't do PDE. We only learn ODE. We only study materials about ODE, the ordinary differential equation. So in the future, you may learn partial differential equation, but not in this class. Okay, this is the first definition, and now let's take a look at the second definition. Second definition means order of differential equation. So order of differential equation is the order of the highest derivative. Okay. Highest derivative in a differential equation. So we can see, so we know what's the order of the differential equation, right? So let's see, this means first order, this means second order, and this means the fourth order, okay? And if we have a differential equation like this one, so if we put a parenthesis, that means order, that doesn't mean power, yeah, right? That means derivative, fourth order derivative. And if we have differential equation look like this, so we know what's the order of this one. Order is for the highest order. So in general, we have a differential equation that's like is given by equation in terms of all those things, and this is equation equals 0. This is any differential equation of order n. This is a general equation. Okay, is any differential equation of order n. So here's just a definition. Don't worry too much. So here, let's take a look at this one. We can say this is example 2. Let's take a look at this differential equation. Okay, this is differential equation with actually order 3, right? So we call that third order differential equation. And this is also linear. Linear means there's no power, so there's no like square thing, no cube power, just means they all like just a linear function. We know linear function x plus b equals y, right? There's no power, okay? In this case, we call that linear. So same thing for differential equation. If there's no power to the derivative, that means linear. This is the second definition. Now let's take a look at definition 3. So in this section, we have a lot of definitions because it's called the terminology. Let's take a look at this one. A differential equation that can be written as this form is called the linear differential equation of order n. Let's see. In the form like this one. Okay, this is like a polynomial. When we write down polynomial, so it's like an x to the power n and an minus 1 n to the power n minus 1, a1x plus a0 equals y. This is called a polynomial, right? So similar to that one, but here we have the derivative, okay, of the function, nth order derivative, and all the coefficients, they are all functions. So in general case, this is a n x y equals f(x). Okay. Sometimes our function can be written as this way. And this is called, and here where all those coefficients, they are functions of x. Okay, and this is called linear differential equation. differential equation because there's no power, right? No power. Okay, no power. That's why it's called linear. It's just a linear combination of all the derivatives. If an equation doesn't satisfy this equation, it's called a nonlinear differential equation. Now we can take a look at some differential equations and let's see if they are linear or nonlinear. The first one, okay, second one, and the third one, let's see. If we look at the first equation, so it's called the first order because the highest order is order 1. And we can see there's no power to y prime and y, so this is linear, right? So the first one is linear. And the second one is also linear. You can move the right side to the left side and, we can change this into the form in our definition. It's going to be like this way, and there's no power to y double prime and y, so this is also linear. Same thing for the third one, no power to those terms, right? So, and the right side is the capital F. Okay, this is also linear. Let's take a look at another one. Okay, so for this one, the first equation, we can see we have a term has y squared, so this is nonlinear. Okay, nonlinear. In our class, at the beginning, we just deal with all the linear differential equations. At the end, we may look at some nonlinear. Let's take a look at this exercise problem. Can you tell this is linear or nonlinear? I'm going to give you another one. Okay. In my class, I always give the example and then followed with very similar exercise problem. When you watch my video, you can pause and start to do the exercise, and then you can check my answer later. And then here, those two are pretty easy, so you don't need to, you don't need to stop and start to do the exercise. We can just take a look. And those two equations, actually, they are all linear. Is that right? Because there's no power to all the derivative o to the y. And for the first one, the right side is the capital F, and that is capital F. That's the right side of the equation. So that's the definition for the general differential equation of order n. Next, we are going to take a look at definition for the solution. Solution to a differential equation is a function that satisfies the differential equation. So what's the solution of differential equation? That means a function y equals fx that satisfies the differential equation. So it's same as this kind of thing. So if we have equation like polynomial, like this equation, and we know the solutions are x equals 2 and x equals 3, actually. Okay. Because when we solve that, it's x minus 2, x minus 3 equals 0. So that means when we plug in 2 and 3 into the equation, they satisfy the equation, make the equation true, right? So same for the solution for differential equation. If we plug in the function into the differential equation, make the equation true. Let's take a look at the example. Example 4. Where you find that for any given constant C1, C2, so let's see. verify that for all constant C1 and C2. Usually for constant we use C. Okay, so but here we have two constant, and this is the function. Function is given by C1 sin x, C2 cosine x. So we say this is a solution to the linear differential equation. So the equation is this one: second derivative plus y equals 0, and for all x in -infinity to infinity. Okay. So we just want to see if our function, the solution, satisfies the equation or not. So let's take a look. In the equation, we have the second derivative. So if we want to plug in our function, definitely we need to find the second derivative, right? So first step, we need to find the first derivative from the given function. The first derivative equals, just to take the derivative of the function, sine derivative cosine, and cosine is sine, negative sine. Okay, so that's the first derivative. And then we do the second derivative of this function. So take the derivative from the first derivative, negative C1 sin x minus C2 cosine x, right? So actually we got those from given the function. And now we plug this into the differential equation and let's see if that's true or not. Second derivative, negative C1 sin x minus C2 cosine x, and the plus y. So we take a look at the function y with C1 sin x, C2 cosine x, and let's simplify. We notice that there are some certain, some same common terms. And sine, negative cosine, positive cosine cancel, so it's equals 0. So we can see when we plug in y, second derivative plus y, it equals 0, right? So they satisfy the equation. So we can say yes, yx is the solution. Okay, y C2 cosine x is the solution, or is a solution to the differential equation. Okay, so this is the example. And now let's take a look at this one, this exercise problem. And we want to test if this is given solution. Okay, is the solution of this equation. Second order linear differential equation. Okay, this is the exercise problem. So you can pause my video now and start to do this one. Here I'm going to give you the solution. So let's check. You can double check with my answer, but it's really good for you to practice by yourself. First derivative. Chain rule, e to the negative 2x derivative, which is negative 2e to the negative 2x, right? Second derivative. Negative 2 times negative 2 becomes 4. Now plug into the differential equation. Okay, be a little bit careful. When we here, I just open the parentheses, so change the sign and 2c2e to the negative 2x, and let's see if we can cancel some terms. So we have c1, and we have negative c1, and they canceled. Okay, and here 4c2 minus 4c2, which is 2. 2 minus 2, they also cancelled. So this equals 0. So you can say, yes, that is the solution. You know, at the end of this quarter, we are going to solve this kind of differential equation. We will find those solutions by ourselves. But right now, we just want to see the other solutions. We want to tell the other solution. Next example, we are going to see implicit solution. So let's see. Sometimes we know this is called explicit function, right? In Calc 4, you learned implicit differentiation. What is implicit differential equation? Differentiation. So implicit function means function is given by a relation. So for example, x squared plus y squared equals 4. This means a circle. This also means if we solve for y, okay, y equals fx, so this is explicit, right? So what is implicit, explicit? Implicit means the function is given by the relation or given by the equation. By explicit, that means we can write out y equals fx. So here we have solution. Let's see. Let's take a look at the example. Verify that this relation defines an implicit differential solution. So here is the implicit and the explicit definition. Solution to this differential equation. This is this is differential equation, nonlinear differential equation. Okay, dy over dx equals negative x over y. Let's take a look at this one. So in this case, we cannot plug in the function like last question, because last example we already have this one, y equals fx, right? But here is implicit. So what should we do here? We do implicit differentiation. So we do differentiate. So think about calculus 1. How to do implicit differentiation? So here we treat or regard y as a function of x. Let's see. When we have this one implicit equation function, we do this, we perform implicit differentiation, and when we do the implicit differentiation, we look y as a function of x. Now derivative of x squared becomes just 2x because the variable is just x, right? But here we need to do chain rule. Chain rule because we look this as a function. If you think about this thing, okay, I don't know if you do remember how to find the derivative of this kind of thing. Chain rule for x squared plus 1 cube, that's the derivative outside function. And we also need to times the 2x, which is derivative inside function, right? And so we can look at this as this thing. So it's 4y cubed. But what is y? Y is a function of x. Okay, function of x. So times y prime. Chain rule. Actually, we learned this in Calc 4 and also Calculus 1. So this is 2y, y prime. Derivative of 4, which is 0. equals 0. And now we solve for y prime. And the y prime, solve for y prime. How to solve that? It's just like equation. And we can move 2x to the right side, negative 2x, and solve for y prime. Negative, actually 2x over, let's see. Okay, so when we move 2x to the right side, we don't change the sign of y prime, right? So it should be negative 2x over 2y, which is negative x over y. And then if we look at this equation, this differential equation is exactly the same as beginning given. So our function, which is given by implicit way, is the solution to this differential equation. Okay, actually we just perform implicit differentiation. If you forgot this, please review calculus 1. How to find, for example, how to find the derivative of, let's see, okay, find y prime. Review. This is in Calc 1. Now let's take a look at the exercise. So when we do the implicit differentiation, just keep in mind we always look y as a function of x. So when we need to use chain rule, just be careful. And we want to see if this is solution to this equation or not. This kind of problem will be in our first quiz. Okay. The function, the solution may be given implicit way or explicit way. So let's see, we do implicit differentiation. And here, if you look at those two terms, it's product of function x with another function of x. So we need to use product rule here. Okay, please do this problem by yourself. You can try. If you made a mistake, you can double check with my answer. Product rule. So it should be product rule is f prime g plus f g prime. F prime, which is just x, okay, 1, and g y squared. F g prime is y squared derivative, so it's 2y y prime chain rule here, right? And here 2y prime and minus derivative x, which is 1, derivative c constant, which is 0. Now solve for y prime. That means we combine all the terms with y prime. So here this coefficient, change the order, 2xy, just combines, make it easy. Okay, plus 2 and y prime, right? And move everything else to right side. So 1 minus y squared. This is just solve equation. So 1 minus y squared over 2xy plus 2. So let's see, we can factor 2 out in the denominator. Xy plus 1, 1 minus y squared. So exactly same as the differential equation. So this is a solution to the differential equation. So we can say this is the first exercise, and I'm going to give you another one, and let's try. We want to show, so this one means yes, okay, show that sin xy plus y squared minus x equals 0 defines a solution to this differential equation. So you can see there's no way to solve y from the implicit equation, right? So this we know implicit. There's no way to solve for y, okay? And we have to do implicit differentiation. And you can try this problem by yourself. Here is the solution. Okay. Chen rule, product rule, actually. Sine derivative should be cosine. And the Chen rule, derivative outside times derivative inside. Y squared derivative 2y prime. Okay. And here, product rule. Combine all the terms with y prime, but we need to simplify a little bit. Distribute. Now combine all the terms with y prime. Factor the coefficient out. Move everything else to the right side. And divide by the coefficient of y prime. Let's see if this is same as before. Given the given function, differential equation, yes, they are the same thing. So this is solution. Okay. Actually, what we are doing here is just implicit differentiation, totally same as calculus 1. It's not difficult. You can try the homework problems. We can stop here for the first class. For our video, it's going to be about just 30 to 35 minutes. In the next class, we are going to finish this section. We are going to solve some initial value problem. Solve some like a differential equation with initial conditions. So next class, we are going to solve initial value problem. Okay, we can stop here.